Hey y'all, welcome to your help video for quiz 3.14. This is the last quiz in unit 3. Hip hip hooray. Alright, so here's your need to know info. Today we're going to be talking about area of a sector of a circle. And that is on your formula sheet, so I wanted to make sure you knew where that was located. Again, R stands for the radius and theta stands for the central angle in degrees. So I'm going to kind of jump over here. I just want to clarify, on the last quiz we talked about arc length, and on this quiz we're talking about area of a sector. Well, those are two different things. First of all, we have theta here, which is our central angle in degrees. Arc length represents like the pizza crust. You're measuring the length of the outside of the circle. And the area of the sector is like the area of a piece of the circle. So today we're talking about area of sector. So we're thinking about a piece of pizza. Now I want to go eat. Just as a reminder, to convert from degrees to radians, you multiply by pi over 180. And to convert from radians to degrees, you multiply by 180 over pi. Conversion is important because in your formula, theta has to be in degrees. So we need to be really good at converting from radians to degrees. Okay, so speaking of this formula, I also want to take a second to talk about what it means. Because I forgot to do that until the very end of the last help video, so I want to make sure I do it right this time. Think about pi times radius squared. Y'all, that is the area of a circle. Pi times radius squared. So really, we could rewrite this formula to say area of a sector equals the area of a circle, pi times radius squared, times theta over 360. And theta is that central angle in degrees. So this red thing down here says the exact same thing that this formula does up here. All I did was I replaced pi r squared with area of a circle, because that's what it is. And I replaced theta with central angle in degrees, because that's what it is. So I just substituted in words. Okay? So for some of us, for me, it's easiest just to use this formula all the time, but you really need to see how it's broken down and what it means when it's broken down. Okay, so it says the area of this circle is 42 pi meters squared. What is the area of a 60-degree sector of the circle? So they give us the whole area of the circle. The whole circle's area is 42 pi, and we want to know the area of a sector. So again, we're going to go back to our formula sheet, and for some of you it's going to be much easier to think of it in words. But this pi r squared represents the area of a circle, which we know in this problem is 42 pi. So I'm going to go ahead and write this out. Area of a sector, which is what we're actually trying to solve for, we don't know that yet, equals the area of the circle, pi r squared, which is 42 pi, equals the area of the circle times theta, which is your central angle in degrees, in this case it's 60, over, you can do all over 360, or you could just do it on this piece. It doesn't matter. It doesn't matter which one you do. So let's figure out the area of that sector. Let's take 42, and y'all notice you have pi in your answer. Remember, if you have pi in your answer, you don't want to type it in your calculator. So we're going to ignore it, and we're going to put it on our answer. So I'm going to type in 42 times 60, and then I'm going to divide that by 360. And that gives me 7 pi. So the area of that sector is 7 pi. Okay, cool. Let's go to the next one. A 45-degree sector in a circle has an area of 13.75 pi centimeters squared. What is the area of the circle? All right, so let's plug in everything we know. We have a 45-degree sector. That's going to be theta. That area of the sector, so this is area of sector, is 13.75 pi. And we want to know the area of the circle, so I'm going to let that be x. So again, if you pull your formula from the formula sheet, it's not quite broken down the exact same way, but pi times radius squared represents the area of a circle. So I'm going to go ahead and plug it in the way that I've written it out. The area of the sector is 13.75 pi. The area of the circle we don't know yet. The central angle is 45, and that is all divided by 360. All right. So it does say use 3.14 for pi. So, oops, shouldn't have put that pi symbol there. Let me substitute in 3.14. Squish it in there. All right, so we're trying to solve this for pi. We want to know the area of the circle. All right, so I'm trying to get, I just said we're trying to solve for pi. We're trying to solve for x, people. This is an equation. We're solving for x. So I need to get rid of this 45 divided by 360. I think the first thing I'm going to do is I'm going to go ahead and divide that out. So, and I'm going to multiply this side out as well. So 45 divided by 360 is 0.125. And then 13.75 times 3.14 is 43.175. And since I'm solving for x, I need to get rid of this number. Right now I'm multiplying. The opposite would be to divide. Those would cancel, leave me with just x. And then I'm going to type that in my calculator. And I ended up with 345.4. And that should be my area of the circle, because I let area of the circle be x. So my area should be 345.4 centimeters squared. All right, what is the area of a sector with a central angle of 10 pi over 7 radians and a radius of 18.4? Use 3.14 for pi, round your answer to the nearest hundredth. All right, so it asks for area of a sector. So I'm going to go to my formula sheet and I'm going to pull the area of a sector formula. Now this time I'm not going to think about it like split up in words like I did back here, because I only split it up like this when I'm given the area of a circle. Since this time I'm given theta and radius, I'm going to keep the formula exactly how it is. So pi times radius squared times theta over 360. Okay, remember theta has to be in degrees. You cannot plug in radians. So to start this problem, I'm going to go over here and I'm going to convert theta to degrees. If I could change the color, where is it at? There we go. So since my central angle is this many radians, I'm going to convert it to degrees. Now remember, I want the pi to cancel, so I'm going to put pi on bottom and 180 on top. That way those pi's will cancel out. And then I can do 10 times 180 and divide it by 7. Oh, geez. Okay, so this is not a pretty angle, which means I'm probably going to get a little bit of a rounding error. So I need to be really, really careful here. I'm going to go ahead and, like when I typed it in, I got 257.1428571 degrees. Well, that is not very accurate. It's an approximation. So I'm going to go ahead and leave this as 1,800 divided by 7 degrees. I don't want to round until the very end, or I could get the wrong decimal. It probably isn't going to make a difference, but I'm just going to try to be careful anyways. So that's going to be my theta. All right. So let's start plugging in what we know. We know for pi, we're going to substitute in 3.14. For the radius, I'm going to put in 18.4. I need to make sure I square it. And then for theta, I don't really want to get this as an approximation. I don't want to just put in 257 degrees because that's not exact. So I'm going to go ahead and leave it like this. And again, it might not make a difference, but I'm a little nervous it will. So let's go ahead and do some calculator work. Let's see. 18.4 squared times 3.14 times, let's see, 1,800 over 7. divided by 360. So when I did this, I get 759.3417, blah, blah, blah. And I want to round it to the nearest hundredth. 100 has 2 zeros, so I need to go 2 decimal places. That 1 is going to make that 4 stay the same. So this would be my area of the sector. Now let me just pause for a minute and go back and see if I had rounded this to 257 degrees if I would have gotten the same thing, just for kicks and giggles. Hang on. Okay, so fair warning. If you turn it into degrees and you just go ahead and round it to the nearest degree, you are not going to get the correct answer for the OHS because the OHS is so picky about how you round it. So if you convert from radians to degrees and it's not an exact degree, just make sure you leave it. Don't turn it into a decimal yet. Just leave it as the fraction. That way you don't round it incorrectly. All right. This one says, what is the area of a sector with a central angle of 5 pi over 7 radians and a diameter of 5.6? Ooh. Okay. So I'm dealing with area of a sector. So I'm going to go ahead and pull my area of a sector formula. Pi times radius squared times theta over 360. We know we have to convert radians to degrees. So I'm going to start with that. I want my pi's to cancel, so I put the pi on the bottom. And then 5 times 180 divided by 7. Again, that's a really ugly number. So I'm not going to round it yet. I'm going to leave it as 900 over 7 degrees. It's about 129 degrees, but that's not exact. And then diameter, there's no place to plug in a D over here, so we need to change that to a radius. And we know to change a diameter to a radius, we divide it by 2. So now I think I have everything I need to plug in. I'm using 3.14 for pi. The radius is 2.8 squared. Again, don't plug in the diameter there. You'll kick yourself later. The degrees, I'm going to leave it as 900 over 7 so I don't get a rounding error. And I want to divide it all by 360. So let's go ahead and do some calculator work. So when I typed all this into my calculator, I got 8.792. And again, it says round to the nearest hundredth. 100 has 2 zeros, so I need to go 2 decimal places. Look at the number behind it. And that's going to make the 9 stay the same. So my area of the sector would be 8.79, what's my units here? Inches squared. All right, last one. What is the area of a sector with a central angle of 4 pi over 5 radians and a radius of 11? So same type thing. We want to know the area of a sector, so we pull the area of a sector formula. Pi times radius squared times theta over 360. We cannot plug radians in for theta. We have to convert it to degrees. So we're going to take our 4 pi over 5 and we're going to multiply it by 180 over pi. Those pi's will cancel. 4 times 180 is 720 divided by 5. Oh, this one is a pretty answer. Yay! So this is exactly 144 degrees. That's cool because then we don't have to plug it in as a fraction. We can plug it in as exactly 144 degrees. So we're going to just plug everything in. 3.14 for pi. Radius is 11. Make sure we square it. Theta is 144 all over 360. And then we're going to do a little bit of calculator work. So I got that the area of the sector is about 151.976, rounding to the nearest hundredth. That would be 2 decimal places. That 6 would make it go up to an 8. And this is in centimeters squared. That's the area of that sector. Hey, if you need help with your calculator, please tell me. Meet with me one-on-one or tell your teacher or schedule a learning conference. Do something because the calculator work is really important. All right, y'all, good luck on this quiz.